Through this video, I plan to explain you in a very simple terms what is duct sizing and how do we do duct sizing by equal friction method. So the problem is as follows. Uh, this is the duct system which has to be designed. You see over here that this duct system has got 3 rooms to be air conditioned. So this is room 1, this is another room 2, and this is the third room 3. So these 3 rooms are to be conditioned using the conditioned air which is supplied through a fan. So this fan is going to supply the conditioned air through these ducts. It will go to this section 1, room 2, and room 3. What is given is that this room or this section 1 is to be delivered 20 cmm, that is 20 cubic meter per minute of the conditioned air. This section 2 is also to be supplied 20 cubic meter per minute of the conditioned air, and this section 3, which could be a large section, a large room, this requires a larger conditioned air supply, which is, let us say, 28 cmm or 28 cubic meter per minute. So this is given in the problem that this is a branch duct system. This is the figure which I am talking about. And there are 3 outlet 1, 2, and 3. Also is given that for maintaining a particular noise level, the velocity, design velocity at this section through the main duct, this is the main duct, is to be maintained as 8 meter per second. So when you are saying that you want to size this duct, what you mean is you are supposed to find the diameter of this duct, 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 and diameter of this duct. So that is the meaning of sizing of the duct. Okay. When you are saying we are following the equal friction method, what we assume is that the friction per meter is to be maintained the same in this ducting system. So let us say that you are maintaining a friction of 1 pascals per meter throughout this. Now how do you find this 1 pascal per meter, or for that you will require to know certain things. So first thing, or the first step in this problem, is you calculate the total flow rate of the fan. So this total flow rate at this fan, how much total air is supplied, is addition of this plus this plus this. So it is 20 plus 20 plus 28, which is 68 cubic meter per minute. So this is the flow, and the velocity is specified 8 meter per second. So from the friction chart, you can calculate the friction rate per meter per unit length, which is 1 pascal per meter. Okay. So how do you get this? So you get this from the friction chart. So friction chart would have the different parameters, like it would have the friction rate, it would have the flow rate, and from that you can calculate the diameter for a given velocity, diameter from the given velocity. So let me show you the friction chart. So this is a friction chart. You'll find here that here the friction, either the friction loss is on the y-axis or on the x-axis, doesn't matter. So you, in this friction chart which is in front of you, you'll find that the friction loss is on the y-axis, which is Pascal per minute, and the flow rate, which is expressed here in liters per second, it is on the x-axis. Okay, and this lines what you see, they are the duct diameters, right? And these lines which you see 1.2, 1.4, 1.5, 1.82, 2.5, okay, they are the velocity lines. They are in meter per second. Okay, so you'll find that the velocities are like this. Okay, and the so you'll find on the friction chart there is a friction loss, air quantity, the duct diameter, and the velocity lines. Okay, so considering this, uh, just a minute. So considering this friction chart, we can find the corresponding diameter. Okay. As I said, the friction chart could be in different units. So one of the unit could be liter per second, or it could be in meter cube per second, the flow rates. Okay, so you must be comfortable with the units, right? So in this case, what I had done is that I have converted the 68 cubic meter per minute into cubic meter per second by dividing it by 60. So that comes as 1.133 meter cube per second, and you know that 1 meter cube is 1000 liters. So this is 1133 liters per second. Okay. So any unit is given, whether it is MKS, SI, you must be comfortable in conversion of that. Now, you can find the duct diameter directly from the friction chart, or you can estimate the diameter by first finding the cross-sectional area, because you are talking about round ducts. Okay, so the round ducts area will be pi by 4 d square, right? And for finding this area, you can use the expression of flow rate upon velocity. So this expression, flow rate upon velocity, gives you the cross-sectional area, which comes as, if you calculate, it comes as 0.1416 square meter, and from that the circular duct diameter can be estimated by, from this formula, you'll get this diameter as d is equal to under root of 4a by pi, which is 0.424 meters, right? As I said, you can also get directly the diameter from the friction chart. Okay, as I was showing you. Yeah, so as I was showing you, let me show you where. As I was showing you here, that the quantity and friction loss, they are represented on the friction chart, and you can treat the diameter directly here. Okay, so here the flow rate is around 1100 1100 cubic meter liter per second. So 1100 would come somewhere like this, say 1000, or this would be 1100, right? And the diameter which we had calculated is 425. Okay, how did we calculate that? So we had calculated the diameter by this 424 0.424 meters. 0.424 meter is 425 mm. Okay, so what we do is that in the friction chart, using this diameter which is 424, so look at this, you'll see that this is the diameter, this is 400 mm, this is 500 mm, so 424 would be somewhere here, right? And you have the quantity of around 1000, slightly more than 1000, right? So if you look at this, if you draw a parallel to this, parallel to 400 at 425, and if you draw a vertical at 1100, you would get the pressure drop of about 1 pascal per meter. Okay, so try doing this on the friction chart. So as I said, first step is what you do is at the main duct. So that main duct means here at this section A, what you are supposed to do is that you are supposed to find the friction drop, that is delta P by here. And so here 1 pascal per meter would be maintained throughout the section, right? Once you do that, now what you are supposed to do is you are then left with determination of the diameters. Okay, how do you determine the diameters? Because now you know two parameters on the friction chart, right? You know the friction rate, which is 1 pascal per meter, and you know the corresponding flow rate, that is Q, at different sections. So at section A, the Q is 1.133 meter cube per second. So directly from the friction chart, you start getting the diameters. Okay, so section B you get diameter 370 mm, section C you get diameter 310 mm, section D you will get 270 mm, E 270 mm, and F 310 mm. So how do you get this? By section B, C, D, E and F, the diameters are obtained directly from the friction chart by using two variables, two parameters. One is the flow rate in that corresponding section, and second is the friction rate. So how much is the friction rate? The friction rate is the one which is calculated in the section A, and which was found to be 1 pascal per meter. Okay, in this problem it would change. So we are keeping in all the sections the friction rate as 1 pascal per meter. Then what would change in section B, C, D, E and F? Friction rate is same, but what would change is the flow rate. And how do we get the flow rate? For finding the flow rate, because you know that section 1, the flow rate is 20 cm, this is 20 cm, and this is 28 cm. Okay, you can find the corresponding diameters. Okay, so here for this 20 cm, which is, you have to convert this. Okay, 20 cm I had converted this to meters per second. Okay, so 68 is 1.133, 20 cm is 0.33, 20 cm is 0.33, 28 cm is 0.467 meter cube per second, and section B is 48 cm. How is section B is 48 cm? You will find here that this is total is 68, and of the 68, 20 goes in the section 1, so section B is left with 48. So just you are doing the subtraction. 68 is being flowing here, of which 20 is applied to 1. So in section B, you are left with 48 cm. So this way, we are determining in each section what is the flow rate. Okay, section A 48, section D 20, section B is 48, 68 minus 20, which is 48, and so on. Okay. So section C is 48 minus 20, which is 28. Okay. So look at this. So this way, if you go on doing it, you will find that you will ultimately get the diameters, and once you get the diameters, okay, that is called as the duct sizing. Okay. So duct sizing is very simple if you have the friction chart with you, and especially with the round ducts, it is fairly straightforward.